from the textbook. Are we done with property 3? Property 4, property 5. Are we done with them? Property 6. The first formula for property 6, are we done with it? When xy is greater than 1 and xy is less than 1. First formula in the property 6. This is the equation which you can note down. Additional new equation. Tan inverse x plus tan inverse y plus tan inverse z equal to tan inverse of x plus y plus z minus xyz upon 1 minus xy plus yz plus zx. Even this will have two different conditions. Xy plus yz plus zx less than 1, xy plus yz plus zx greater than 1. The only reason behind this would be if the denominator is negative, then the total term will be negative, and tan inverse negative will give you a negative angle. But on one side, you would be expecting a positive angle as x, y, z are individually positive. So, what we have to do in this case? Again, two cases. Xy plus yz plus zx less than 1 and xy plus yz plus zx greater than 1. Got it, all of you? And what in the case of xy plus yz plus zx greater than 1, the formula will remain same, but you will just add pi radians to it. That's all. And you know the reason why. Got it, all of you? So you may please note down this formula. I have sent you the PDF regarding the same. You may please go through it once again. And you can use the same formula in this question. Prove that sine inverse plus sine inverse plus sine inverse equal to pi by 2. All the sine inverse can be converted into tan inverse. And you know this how to do this. Sine inverse 1 by 3. Draw right angle triangle. Call this as theta. 1 by 3 is nothing but opposite upon hypotenuse. So this will be root 8. Yes or no? That is 2 root 2. So sine inverse 1 by 3 will be tan inverse 1 by 2 root 2. Yes, all of you. Sine inverse 1 by 3 equal to tan inverse 1 by 2 root 2. In the same way, sine inverse 1 by 3 root 11. So what will be the changes here? 1 upon 3 root 11, opposite upon hypotenuse. So this will be root 98, I guess, because the square of this is how much? 99. This is the square of this is 1. So the square of this is going to be 98. So shall I call this root 98? So which is 49 twos are, that is nothing but 7 root 2. So tan sine inverse 1 upon 3 root 11 is tan inverse 1 upon 7 root 2. Yes, are you getting this? And what about sine inverse 3 upon root 11? 3 upon root 11, this is going to be simply root 2, because the square of this is 11. The square of this will be 9. So the square of this should be 2. So this will be root 2. I hope you have understood this. So tan inverse x plus tan inverse y plus tan inverse z will be, they have solved 2 at a time and they have then gone for the third one. You can also use the above formula, but this will be comparatively a bigger one. So in that case, you can use 2 and then go for the third. Anyhow, you can do it. Even if you do not remember this formula, eventually you will be able to solve this by the formula which we have learned yesterday. tan inverse x plus tan inverse y is tan inverse of x plus y upon 1 minus xy. And if x, y, z are very simple and straight, like integers, I say, then you can straight away go with this formula. Now, these are all fractions. It would be difficult for us to add them and product and all those things to carry out. If x, y, z all are integers or very simple fractions, which you can deal with, then you can use this formula. Okay. Now it doesn't make any difference if it is sine inverse or cos inverse or cot inverse. You can convert everything in the terms of tan inverse. Yes or no? Simply we have to go to the triangle. Sine inverse 3 upon root 73. 3 upon root 73. The square of root 73 is 73. The square of 3 is 9. So this should be 64. So that is 8. Yes or no? 8 square will be 64. So it will be tan inverse 3 by 8. Yes. Sine inverse 3 by root 73 is tan inverse 3 by 8. I guess now you would be able to do this. I'll show you one for cos inverse. Cos inverse 11 by 146. I will always refer this base angle. 11 upon under root 146 will be 11, and this will be under root 146. The square of this will be 146. This will be 121. So simply this is 25, which is nothing but 5. 25 plus 121 would be 146. So cos inverse of 11 by 146 is tan inverse of 5 by 11. Yes? Do you agree with this? And cot inverse root 3 will be simply tan inverse 1 by root 3. Or straight away you can use the value of cot inverse root 3 as pi by 6. I hope you have understood this. Same kind of questions. Look at this example. Tan of 1/2 cos inverse 2 by 3. The same kind of example we had solved yesterday. We had called this cos inverse 2 by 3 as theta. So therefore cos theta will be 2 by 3. Yes or no? Cos theta will be 2 by 3 and the expression will be tan of theta by 2. Expression will be tan of theta by 2. Do you all agree? We had solved the same kind of example. And according to the formula, tan of theta by 2 is under root 1 minus cos theta upon 1 plus cos theta. We had learned this as well yesterday. Because you all know 1 minus cos is 2 sine square and 1 plus cos is 2 cos square. Yes, 2 sine square upon 2 cos square, 2 will get cancelled. Sine square upon cos square will be tan square. The square root of tan square will be tan. Got it, all of you? The same thing has been written here. And you know the value of cos theta, which is 2 by 3. You simply put it in this and you will get the value of tan theta by 2. That is the first expression. Will you get it, yes or no? All of you. First expression clear? Look at the second one. Tan of 2 tan inverse 1 by 5 minus 5 by 4. Again, I'll call this whole as theta, not the 2 part, only the leftover part as theta. Then the expression will be tan 2 theta. And I'm calling tan inverse of 1 by 5. Just a second, I will have to check whether pi by 4 is a different value. Yes, pi by 4 is completely different. 2 tan inverse 1 by 5 minus pi by 4. So what we will have to do is call this tan inverse 1 by 5 as theta. We'll just call this tan inverse 1 by 5 equal to theta. So therefore tan theta will be how much? Will it be 1 by 5? Yes, all of you. Tan theta, will that be 1 by 5? And the expression will be tan of 2 theta minus 5 by 4. Yes or no? The second expression will be tan of 2 theta minus 5 by 4. Now if you expand this, tan A minus tan B upon 1 plus tan A tan B, that is tan 2 theta. Yes? Will this be the case? Now simply do one thing, because tan pi by 4 will be 1, no? So tan A minus B is tan A minus tan B upon 1 plus tan A tan B. So this will be the expression. Now to find the answer for this question, which value do you really need here? Looking at this answer, what is the value you need here? You need tan 2 theta. Yes, you need the value of tan 2 theta. If you get the value of tan 2 theta, will you be through the answer? If you get the value of tan 2 theta, will you get to the answer? Yes, you will get to the answer. So to find the value of tan 2 theta, what do we have? We have the value of tan theta. How much is that? It is 1 by 5. So is it helpful? Can you find the value of tan 2 theta when you know the value of tan theta? Do you know any expression which equates tan 2 theta in the terms of tan theta? Have you learned this formula? Two tan theta upon 1 plus tan square theta. So will you just put down the values and get the value of tan 2 theta? All of you? Will you be able to get the value of tan 2 theta? And whatever value you get, subtract 1, add 1 to it, you will get the final answer. Got it, all of you? Did you get this? The same kind of question you can see here. Prove that this plus this is 2b upon a. Again, a simple question. Call this much as theta. Tan of pi by 4. So the expression will be tan of pi by 4 plus theta by 2. Yes or no? Expression will be tan of pi by 4 plus theta by 2. And what will be the expansion of this for the first expression? And cos inverse a by b is called as theta. So will cos theta be equal to a by b? Will cos theta be equal to a by b? This term is called as theta. And you can see cos inverse a by b in the second term also. So if ever we call that as also theta, will the expression be plus tan of pi by 4 minus theta by 2? Tan of pi by 4 plus theta by 2 plus tan of pi by 4 minus theta by 2. Yes? Shall we expand them? Tan of a plus b, tan a plus tan b upon 1 minus tan a tan b plus, what the second term? Tan a minus b. So tan a minus tan b upon 1 plus tan a tan b. Now simply you tell me, if we just cross multiply this square plus this square upon a minus b into a plus b will be a square minus b square. Yes or no? This is 1 plus tan theta by 2 bracket square. If you simply go on simplifying this further, you can see what has happened here. Now you all know a plus b bracket square plus a minus b bracket square. What is going to happen in this? The plus 2ab and the minus 2ab will get cancelled. Yes or no? So will it be 2 into bracket 1 a square plus b square? Because a square plus b square will be left here, a square plus b square will be left here. So is this correct? 2 into bracket a square plus b square. And in the denominator will be 1 minus tan square theta by 2. Will that be 1 minus tan square theta by 2? Now look at this formula. 1 plus tan square theta by 2 into 1 minus tan square theta by 2. Is it 2 into cos theta? Is it the formula of cos theta? Simple to understand. If ever you do not recall this, you can simply replace tan square as sin square upon cos square. You'll get back to that formula. But anyways, you should be able to recall this. Is it cos theta? And you know the value of cos theta is a upon b. Why would that? Okay, yes, cos theta will be a denominator because 1 minus tan square upon 1 plus tan square is the formula. 1 minus tan square upon 1 plus tan square is cos theta. This is the reciprocal, so cos theta will go in the denominator. Got it, all of you? Got it? How to solve this kind of questions? Everyone? Fine. This is a very simple question. I would not want to discuss this. Cos inverse, sin inverse, tan inverse. Convert everything and you will get the answer. But the important thing in this question will be the two new formulas which you are going to learn. The same like tan inverse x plus tan inverse y. And that is something I want you to focus on. Just a second, I'll see where the exact forms have been given. Let us check. There are formulas for sin inverse x plus sin inverse y, as well as cos inverse x plus cos inverse y. Let us check. Not given here. But even those are very much helpful while solving, because not everything is always in the terms of tan. No? They ask the question, you cannot expect every time in the terms of tan. You can see here, I'll frame the formula for you. Please pay attention. Cos inverse x minus cos inverse y is equals to cos inverse of xy plus under root 1 minus x square into under root 1 minus y square. Cos inverse x minus cos inverse y is x into y plus under root 1 minus x square into under root 1 minus y square. And if this is plus, this will be minus. If this is minus, this is going to be plus. I guess they have given this. We'll just check it once. Just a second. Now I'll do one thing. I'll just write down those formulas. You please note down it. Cos inverse x plus cos inverse y and cos inverse x minus cos inverse y. It will be cos inverse of xy minus under root 1 minus x square into under root 1 minus y square. And this will be the same thing, xy plus under root 1 minus x square into under root 1 minus y square. Yeah, these formulas are going to be used. It's all up to us. If we have the habit of changing always in the terms of tan inverse, we can use only the original formula. But I feel that these formulas are important. It can be used in many cases. Okay, so please write them. And simply, if you just try to look at the formula, you will see cos A plus B and cos A minus B relatively. What have you learned for cos A plus B? Is it cos A cos B minus sin A sin B? Cos A plus B? Yes, cos A plus B. Is it cos A cos B minus sin A sin B? And cos A minus B? Is it cos A cos B plus sin A sin B? To go from cos to sin, do we always do 1 under root 1 minus cos square? Under root 1 minus cos square? Yes or no? So this will help you to recall the formula. And simply, you can do it for sin inverse x plus sin inverse y as well. What will be the formula of sin inverse x plus sin inverse y? Sin inverse of sin A cos B plus cos A sin B. So x into under root 1 minus y square plus y into under root 1 minus x square. I do not remember the formula, but looking at this and looking at the basic concept, I surely tell you that this can be the formula. And sin inverse x minus sin inverse y will be sin inverse of x under root 1 minus y square minus y under root 1 minus x square. Got it, all of you? I have recorded this, so you can also refer the recorded session, and I hope now you have understood what I want to say. So please write down those formulas. Can you hear me, all of you? Please pay attention. So simplified inverse function. Now you will notice one thing here. 2 into x into under root 1 minus x square. So if we simply put x equal to sine theta, will this be 2 sine theta cos theta? If you put x as sine theta, will this be 2 sine theta cos theta? So will that be sine 2 theta? And will that be 2 theta? Yes. Yes or no? Now simply look at these 3 different cases. If you understand this, you will understand all the rest of our properties. So 2 theta. If you see theta is sine inverse x. Yes, theta is how much? Sine inverse x. So 2 theta will be 2 sine inverse x. So can you see the term 2 sine inverse x in all the 3 cases? Can you see the term 2 sine inverse x in all the 3 cases? So did you get to know how this 2 sine inverse x has come? How this 2 sine inverse x has come? Now simply my next question would be to just maintain the principal value branch. What is the principal value branch of the sine inverse function? What is the principal value branch? Is it minus pi by 2 to plus pi by 2? Irrespective of whatever is written inside, sine inverse does not care. He always says that my principal value branch is minus pi by 2 to plus pi by 2. Yes or no? Now you just look at this. Now this is the formula which we have to use if x is ranging between minus 1 to minus 1 by root 2. Let us ask ourselves, why have they done this? Why have they done this? I'll tell you. Please pay attention. First of all, minus pi would be going in the clockwise direction. Yes. If this is plus pi, this is minus pi. So looking at this minus pi, let me recall that this is my original position. Okay, minus pi. Now, if x is negative, isn't it quite obvious that the value or the value of sine inverse x is going to be negative? Yes or no? If x is negative, it's obvious that sine inverse x will be negative, or rather it would be lying between minus pi by 2 to 0. Or rather, I would say minus pi by 2 to minus pi by 4. Will the angle lie between minus pi by 2 to minus pi by 4? Please tell me, all of you. Looking at sine inverse x, just focus on sine inverse x. So the answer, total answer would be minus pi minus 2 into values ranging from minus pi by 2 to minus pi by 4. So if you multiply 2 to this, what you're going to get, if you just look at this, it will be minus pi minus 2. If you multiply, it would be the values ranging from minus pi to minus pi by 2. Yes or no? And if you open the bracket, the two ranges you will get minus pi plus pi and minus pi plus pi by 2. So will that be 0 to minus pi by 2? Will this be the case? That is the fourth quadrant, which we already need. Yes or no? Now just imagine if we would not write this minus pi. Our ranges would be, what would be our ranges? Would that be minus pi to minus pi by 2? Just eliminate the minus sign also. If you just if you multiply 2 inside, what the range would be? Minus pi to minus pi by 2? Yes. And is this okay for you? Minus pi to minus pi by 2, that is the third quadrant. Is it okay for you people to give the answer in the third quadrant? Yes, tell me, is it okay? It is not. So it's quite obvious that we have to add those pi radians or subtract those pi radians, whatever accordingly comfortable. Got it, all of you? If the values are negative, then we have to subtract it from minus pi. And if the value is positive, we have to subtract it from plus pi. Did you get the logic? All of you, did you get the logic why the values and the angles are ranging? And the same applies for each and every term here. Cos inverse 2x square minus 1. Simply if you put x as cos theta, will the formula of cos to theta, will this be the formula of cos to theta? If x is cos theta, 2 cos square theta minus 1 will be cos to theta. Cos inverse cos will get cancelled. You will be left with 2 theta, which is nothing but 2 cos inverse x. Now again, you can see 2 cos inverse x in both the terms. Only the adjustment of the angles is done to take care that the final answer stays in the principal value branch. So this is strongly associated with principal value branch. Yes or no? This is strongly associated with principal value branch. Will you just write down these formulas given in this simplified inverse trigonometric functions, all these formulas? Will you just note them down later? Okay. Now you can see, look at the examples. The examples are really simple. You need not worry about any of the examples. Cos inverse x root 3 plus cos inverse x equal to pi by 2. And you have to solve this. Find the value of x for which cos inverse x root 3 plus cos inverse x equal to pi by 2. Now I would not look at whatever they have solved. Just I would focus on whatever formula I just now learned. And can I write pi by 2 as cos inverse of 1? Sorry, cos inverse of 0. Can I write pi by 2 as cos inverse 0? And just now you are focused on cos inverse x plus cos inverse y. What did you learn? Cos inverse of xy, that is x square into root 3 minus under root 1 minus 3x square into under root 1 minus x square. Yes or no? Equal to cos inverse 0. Do you all agree with this? Yes. Do you all agree with it? So it's quite obvious that the value which is written inside the bracket should be equal to 0. So simply your equation will come down to x square. I'll write this root 3 as a coefficient. Root 3x square minus under root 1 minus 3x square into under root 1 minus x square. This should be equal to 0. So if you transfer this on the other side, both the terms will be equal. Now, how do you solve the value for x? Should we square on both the sides? Yes. So is this a quadratic in x square? If you put x square as m, will this look as 3m square into 1 minus 3m into 1 minus m? And simply with the use of quadratic, will you be able to solve it? Will you be able to solve it? You have to just take care that the value of m should not be negative, because m is nothing but x square. Yes, all of you? So accordingly, you can solve it. So simply also in this way also you will get the answer in 3 to 4 steps. Okay. And I guess if you expand this, on the right side, I can see the 3m square being formed. 1 minus 3m minus m plus 3m square. So simply your 3m square is going to get cancelled. 1 minus 4m equal to 0, m equal to 1 by 4. M was how much? X square. You get the same value here. X square equal to 1 by 4. Did you get it? X square equal to 1 by 4. In this case as well. So x is plus minus 1 by 2. Now you just imagine whether you can use minus 1 by 2. And accordingly, verify for both the values. For x equal to plus 1 by 2, the equation is getting satisfied. X equal to minus 1 by 2, it is not getting satisfied. Just verify it. So only x equal to 1/2 is the solution. Got it, all of you? Did you understand this? Everyone, please tell me. So the summation, the last remaining part of the series is the summation series. I'll do it tomorrow. Till then, you try completing the MCQs regarding the same. Okay? How many MCQs are possible? Please see, go through it and try completing them. Okay? Chalo. Fine, then I'll. Or rather, do one thing. Please join again. I'll tell you which MCQs to complete. Please join again. I'll tell you which all things to do. Okay? Please join again.